Well, today's big. This is going to be a thing. We have reached a point where you're going to get to learn something that is maybe even the biggest, most important formula in all of algebra. Really, really big deal. And I'm really excited about it. I hope that you kind of got the hang of completing the square yesterday. Like I said, it's effective. It's not the cleanest or easiest thing to do, and it can get really messy. But what I'm going to show you today is guaranteed to work on every single quadratic equation you could ever come across. So to recap, remember we started with this idea that, look, we can factor quadratics. And once we have these two factors, we use this thing called the zero product property, set each factor equal to 0, solve for x, and that gives us not only the solutions to the equation, but it gives us an idea of where the graph crosses the x-axis. There's a whole lot of interconnected concepts there. Then we saw, well, sometimes they're even easier than that. We can just solve by taking a square root. You had a couple of those on the quiz, and you just sort of get x squared by itself, take the square root, plus or minus, and off we go. And then we have this situation with a complete the square. We're like, okay, I can't factor it. It's not going to be an easy one to take the square root. But if I can complete a square, then that kind of allows me to solve these more complicated problems. But as I've mentioned, and I didn't really show these to you specifically, there are some situations that are really, really complicated, even when you try to complete the square. And so we need something even bigger. So we are going to deal with this thing called the quadratic formula. And I call it the big one. I want to sort of share this with you here. Some of you have seen this before. This is from Lord of the Rings. One ring to rule them all, right? And that's kind of what the quadratic formula is. It's one formula, one equation that solves them all. So it's super, super powerful, but it takes a little bit of work. So what I'm going to do is I'm going to show you what the formula is and a little bit what it looks like. And then we're going to take a little pause. I'm going to show you a couple cool videos that I will also link to on the website so you can watch these again. And then we'll come back and start working with it. So sit back, enjoy the ride. All right. So when we have a quadratic equation, it's going to look like this. Ax squared plus bx plus c equals 0. That's called the standard form of a quadratic equation. And specifically, I want to make sure that we're always able to identify what these three values are. Okay? So, and we'll practice that in just a few minutes, looking at different examples and figuring out what A, B, and C actually are. What I'm going to give you now, and this is mind-blowing the first time that you see it, but I'm going to give you one formula, one, that will take us right from this equation here all the way down to a solution. Isn't this what you've always dreamed of? Like, you don't have to do all the intermediate steps. You just got one step, and it gets you what the answer is. Now, in defense, it's a pretty big step. It's just one step. Here it goes, all right? Hold your breath. When I have a quadratic equation of this form, ax squared plus bx plus c equals 0, x is found by taking the opposite of b plus or minus a big old square root. And you've probably seen plus or minus square roots like yesterday, right? B squared minus 4ac all over 2a. Hey, that's it. That's the quadratic formula. Was I right? One formula, but man, what the heck? Okay, a couple things here. First of all, A is A, and B is B, and C is C. So it's all there in the problem for you, just a matter of putting them in the right spot. And I want to be clear, when you get to Algebra 2, I'm going to show you exactly how this equation leads to that formula. But we're not going to do it here because it's not going to be really productive for us right now. I just want you to be able to use the formula and understand how powerful it is, and that it's not quite as intimidating as you might think. So with that, I want to switch back here for a second, back to this. And I'm hoping this is going to work. I've tried this a couple times. I hope this is going to work. I've got 2 videos for you. One I might play most of the way through. The other I'm just going to play the first little part. If you want to go and lose an hour or so of your life, but it's kind of productive, go to YouTube and just search for quadratic formula song. You see it says harmony on here. There's a very specific one here. But just search for quadratic formula song, and you will see more videos made for this than you can even fathom. But here we go. Let's try this and see if I can get this to work.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
You got it? In case that's not enough, I got another one formula for you. This is like a whole story. It is 4 minutes long. I'm not going to play the whole 4 minutes. I'm just going to play the first little segment of it, and then we'll get to work on this. All right, here we go.
I saw a man on the street with a parabola in his hand. He said, "Sir, please help me. I don't understand, and I've been having troubles. This problem's all my fears." So I took out my notebook and I wiped away his tears with the quadratic formula. Quadratic formula. Quadratic formula. The quadratic formula. And is negative b plus or minus the square root of b squared minus 4ac over 2a, over 2a, over 2a.
Okay, that's just a minute of it. There's 4 minutes of it. You get more of that later. Okay? So there should not be too much trouble memorizing this because lots of ways you can practice it and memorize it. So let's figure out how this works, all right? I want to start with a couple of examples that will just help you identify the values of A, B, and C. Okay, so we're going to go with this. Let's go x squared plus 4x plus 3 equals 0. Now, I want to make something really clear. There are some problems we'll do, like this one, that we could certainly do by factoring. I could factor this into x plus 3, x plus 1, and get solutions from that. So this is a case where factoring is actually going to be easier than using the formula. But ultimately, the formula always works. Factoring doesn't always work. So anyway, all I want to know here is what is A, what is B, and what is C. Okay, we'll get to applying to the formula in just a minute, but what is A, B, and C? I hope you found that A is that mysterious 1 that we don't always write in front of equations, but we know it's there. And B is 4, and C is 3. Okay, let's do another one. Now this is going to be 2x squared minus 5x plus 3 equals 0. And I want to know what A, B, and C are equal to. Well, A is the number in front, which is 2. Now you got to be careful here though, because B is not just 5, it's actually minus 5. So when I go back over here and I have this minus sign in front of the B, that means the opposite of B, which means I would actually turn that when I did applied the formula into plus 5. And then C is 3. Okay, let's do one more. And this one is going to look like minus 5x squared plus x plus 7 equals 0. Remember what A equals, B equals, and C equals. I'll give you a chance to think about what that should be. A is the number in front, so that's going to be minus 5. B is the number in front of the x, which again we're going to label as 1, and then C is going to be 7. So look, we could do this all day if we wanted to, figuring out what the values of A, B, and C are going to be. But what I want to do is actually solve one of these. And I'm going to pick this one right here, this one in the middle, and we're going to use the quadratic formula to solve this. I think just by looking at this could be factored, but we're going to do it like we didn't know that. So let me write this again. We have 2x squared minus 5x plus 3 equals 0. And I know that A equals 2, B equals minus 5, and C equals 3. Okay? So let's go to work now. Let's figure out what x equals. Remember, one equation, one formula. Yeah, it's a little bit messy, but there's just one. X equals the opposite of B. Remember, I'll write it over here. X equals, we say negative B, but it really means opposite of B, plus or minus the square root, B squared minus 4AC. Okay? So X equals the opposite of B, that's going to be just 5, plus or minus the square root. Now, B squared means I've got to take this entire number and multiply it by itself. So no matter what the sign of B is, B squared is going to be positive. Minus 4, A is 2, and C is 3. All over 2. So that looks messy, right? But watch what's going to happen now. This is kind of cool. 25 minus, what's 4 times 2? 4 times 2 makes 8. 8 times 3 makes, 24. So this is 5 plus or minus the square root of just 1. Remember, 25 minus 24, all over 4. And you should know that the square root of 1 is just 1. So this is 5 plus or minus 1 over 4. So how do we tackle that? Well, we do both versions. We do 5 plus 1 over 4, and we do 5 minus 1 over 4. Now 5 plus 1 over 4 is 6 over 4, which reduces to 3/2. And 5 minus 1 over 4 reduces to, is 4 over 4, which reduces to 1. So the solutions to this quadratic equation are x equals 3/2 and x equals 1. So was I right? It's a messy formula, right? I mean, it takes some work, and believe it or not, this is one of the easy versions. But it's just one formula with all numbers in it. All we have to do is really keep our numbers straight and take our time going through it. Now, something kind of interesting happened here when I did this 25 minus 24 and got the square root of 1. That number came out to be a nice number. I want to switch back. I'm going to switch back and forth with a couple things here, and I'm going to show you a couple things. I'm going to tackle maybe even 4 kinds of problems here. Let me show you this. The first one's going to be x squared minus 8x plus 16 equals 0. The next one's going to be x squared minus 8x plus 12 equals 0. Then x squared plus 8x plus 20 equals 0. And finally, x squared plus 8x plus 6 equals 0. Okay, now those all, whoa, what am I doing here? Sorry. Let me fix this. I want these both to be, all to be minuses, sorry. So I want these all to be x squared minus 8x, and then it's just a matter of what we add to the last term. Now I'm going to switch over to the computer screen again, and I want to pull up Desmos, and I'm going to show you a little bit about what these look like. And this might be a little bit tough to see, I understand that, but this is the first one, x squared minus 8x plus 16. Now I've got a graph. I want you to make a connection here. I've got a graph here as y equals. Over on the equation I had, it said all this equals 0. So what I'm looking at is where this graph has y equals 0. That means the x-axis. I want you to notice that this one graph hits the x-axis in one spot only. It's right there, 4, 0. Okay, remember that. Hits the graph in one spot only. Let me show you what the quadratic formula looks like when I tackle it here. X is going to equal negative b, which is 8, plus or minus the square root of b squared, that's going to be positive, 64, minus 4ac all over 2, 2a, 2 times 1. But I want you to focus specifically on this value right here. This value is 64 minus 64 equals 0. So I'm doing 8 plus or minus 0. Something unique happens when I take the square root of 0. I don't add or subtract anything, and the answer just comes out to be 8 over 2, which is just 4. I know I'm supposed to get 2 answers, but I only get 1 when that square root was 0. Now, if I go back here, you'll see what it looks like to have one answer or one solution. It just touches the graph in one spot. Okay, now watch this. I'm going to change, oh, good heavens. I'm going to change to 12. And now you notice the graph at least crosses the x-axis twice. Once at 2, 0, and once at 6, 0. So what does it look like to get these 2 answers in the quadratic formula? Well, let me go down here. X equals, again, same thing, negative b, 8 plus or minus the square root of 64 minus, now it's going to be 4 times 1 times 12 all over 2 times 1 or 2. So now what does this look like? This is 64 minus 4 times 12 is 48, which equals 16. Now what's interesting to us about 16? The square root of 16 is just 4. It comes out to a really nice number, kind of like I had the square root of 1 there. Now I have the square root of 16. This becomes 8 plus or minus 4 over 2, which leads to 8 plus 4 is 12 over 2, so 6. 8 minus 4 is 4 over 2, which is 2. If that went a little bit fast, I understand and I apologize, but I want you to see these numbers 6 and 2. Because when I go back here, you're going to see the numbers 6 and 2. So there's something that happens with that square root. Let me go back here again and show you this. The square root is kind of a big deal. When the square root was 0, it led to just one answer here. But when the square root was a perfect square, it led to 2, we'll say, nice answers. Now, what happens in this one over here? X equals negative b, 8, plus or minus. You can follow along with me or get ahead of me. This squared will be 64 minus 4a, and now c is 6 over 2. So now what does this square root look like? Is 64 minus 24, which is 40. So I have 8 plus or minus the square root of 40 all over 2. Yeah, yeesh. That still is going to give me 2 answers. You see that? It'll be 8 whatever. I don't know what the square root of 40 is. But 8 plus that over 2 will be an answer. 8 minus that over 2 will be an answer. But what does it look like on a graph? Watch this. 2 answers. They're just not pretty answers, so to speak. So let me change the 12 to, what do I have, 6? And so once again, what you see here is there's two places where the graph crosses, but that's that not very pretty spot. That is 8 plus the square root of 40 all over 2. And this one, can you guess what this is? It's 8 minus the square root of 40 all over 2. So if you have a number under this radical that isn't a perfect square, well, you're still going to get 2 answers here, but they're not going to be pretty answers. They're going to be kind of messy answers. So real quick, we have a situation where the number under the radical was 0, and we ended up with 1 answer. We have another situation, and these are both the same, where the number under the radical was not 0, it was positive, and in both those cases, we got 2 answers. Now I want to show you what happens if the number under the radical is like what it is here. X equals negative b, 8, plus or minus the square root. B squared, 64, minus 4 is 1, times 20, all over 2. Now what's about to happen? Can you see it? What's the number under the radical? 64 minus 4 times 20 is 80. I get negative 16, and I'm asked to find the square root of negative 16. Can't do it, right? I can't do it. I can't do it. So there is no x equals for this problem. What does that look like on a graph for there to be no x equals? I'm so glad you asked. I will show you. So over here on Desmos, what I'm going to do is change this number to 20. And what you'll see here is that there's no place where the graph crosses the x-axis. There's no solution. There's no solution. So we now have these 3 cases for the square root, which means that number under the square root is kind of a big deal. It's such a big deal. It might be the most important number in algebra. It's such a big deal, it has a name. It's called the discriminant. I want to talk about something that could be a little bit painful for some of you. The word discriminant has essentially the same meaning as discriminate. And some of you may be in a family that has experienced discrimination in your lifetime, for whatever reason. What I want to help you understand about the English language is that the word discriminate didn't originally mean treat people badly because of the color of their skin or something else. Discriminate has traditionally meant to distinguish one from another, to separate, or to tell the difference between. Like someone with discriminating tastes in clothes can tell whether something looks really nice or something is kind of sloppy. Discriminating taste in art means they can tell when an art is really good or not really good. The way that the word discriminate has been used to become a negative in our world is where people decided that other people were good or bad people based on color of their skin, their preferences, their name, the language they speak, whatever. But to discriminate is not inherently to treat people bad based on those things. So this word discriminant is actually in the original meaning of the word, which is a distinguisher. The discriminant is simply the number b squared minus 4ac. Remember, the formula looks like this. Okay, the discriminant is only this number. It's not the square root, it's just the number. And here's the thing. If the number is positive, then that means I can take a square root plus or minus, and I get two solutions. Like x equals 5, x equals 3. If the discriminant is 0, like we saw in that first example, we get just one solution. Maybe I better go back here. Remember up here, our discriminant was 0, and we got just one solution. But where we had a positive discriminant, we got two zeros, the two answers. And then if it's negative, there's no solutions. And that's this situation down here where the discriminant was negative. So the discriminant can tell us very quickly what type of answers we can expect. So I'm just going to give you a problem. I'm just making this up. I don't have this in my notes. I don't have any. I'm just going to make this up. 3x squared minus 2x minus 5 equals 0. What I want to do real quickly as we wrap this up is first of all use the discriminant to decide how many solutions we're going to expect, and then we'll find those solutions. Okay, this is going to be the wrap up so you can really see how the quadratic formula works. So discriminant is b squared minus 4ac. That's going to be this number squared, which is 4. Remember, minus 2 times minus 2 makes plus 4. Minus 4 times a. Now be careful, there's a minus sign there, minus 5. So what do I get for my discriminant? 4 minus, well, see what? See this minus here and that minus there? That's actually going to turn to a plus. I get 4 times 3 is 12. 12 times 5 is 60. So I get 64. So what's the result going to be? It's positive. So I'm going to have two solutions. Now, through a stroke of luck, I happen to come up with one that's going to work out really nicely for us, which is always kind of nice. So what's the answer here? X equals, let's do this. Negative b plus or minus the square root of b squared minus 4ac. Are you starting to see how pretty eventually you're going to get this memorized? All right, negative b is 2. Got the opposite of b, plus or minus. Now we know the discriminant was 64. This will be the square root of 64 all over 2a. Okay, we know that the square root of 64 is 8. So this gives me 2 plus or minus 8 all over 6. And this is where we separate into two problems. Okay, 2 plus 8 over 6 is 10 over 6 is 5/3. That's an answer. 2 minus 8 over 6 is negative 6 over 6 was negative 1. So what do we just do? We found a positive discriminant, which means there's two solutions. Then we applied the quadratic formula and found those two solutions is x equals 5/3, x equals negative 1. And that's how the game goes. Guys, this is the most powerful tool, I think, at least in Algebra 1 for sure. It's a little bit daunting at first, but it's so cool because it works every single time. So you're going to get a chance over the next several days to practice this. All right, here's your assignments. Number 12. Oops, that's weird. Number 12 is going to be out of your book, page 393, 6 through 13, and 23 through 30. It's going to be a lot of find the discriminant, tell how many solutions there are, and then some problems where you're actually going to find those solutions using the formula. Assignment 13 is going to be a CUDA worksheet, but it's the quadratic formula 1. And this will be next week. So this is Friday, Monday, Tuesday. So you'll see this next week. I want you to pick, and I'll put this on the assignment sheet too, any 10. So there's more problems than that. You want to pick all the easy ones, find them. You do 10, that's great. Maybe you might pick all the hard ones, I don't know. Then on Tuesday, we're going to do another CUDA. It's a quadratic formula. I'm going to call it number 2. It's a different worksheet. And I want you to do just 1 through 10. So just 10 questions each day. And then on Wednesday, we're going to have a quiz. And you're like, wait a minute, we just had a quiz. I know. That first quiz was on the first little part of it. I want to give you a chance to just practice the quadratic formula and a little bit of complete the square. So that'll be that for that quiz, just those 2 topics, complete the square and mostly quadratic formula. Then Thursday, we'll start a review assignment. Friday is going to be a study day. You can ask me questions, you can review, you can start your test if you want. Then your chapter 9 tests will be due by May 4th. It's a Monday. Okay, this right here is May 1. If you're keeping track, we're going to be May already. Chapter 9 tests can be due by May 4th, that Monday. So yeah, you got a little bit of quizzes and testing to do, but this is all just going to help you focus your attention on how you're doing what you're doing. And I hope you do really well. I hope you like quadratic formula. I love it. I think it's great. Watch those little videos. I'll link to them on the website. YouTube videos are great. You can find a whole lot more. And I don't know the next time I'm going to see you. I'm looking at my calendar. It could be a little bit before I see you again. So, hey, keep in touch. Drop me a text, shoot me an email, ask me questions, ask me for some help on your homework if you're struggling. For sure, take the quiz that's just over. And also take this quiz next week and then get ready for your test. And May is right around the corner. See you next time.